We're going to go back to our luggage problem that we had at the beginning of this section to give us an idea of why we might need this, just an example of why we might need this. If you recall, we wrote a volume function, x times x plus 10 times 30 minus 2x were the three dimensions of this piece of luggage. And the question was determine two possibilities for the depth of the luggage if its volume is 2,000 cubic inches. When we did that, and you could go back a few pages, we came up with this equation. Zero equals negative 2x cubed plus 10x squared plus 300x minus 2,000. To make this a little bit easier, I'm going to divide both sides of this equation by negative 2. That gives me 0. 0 divided by negative 2 is still 0. X cubed minus 5x squared minus 150x plus 1,000. We could sit here and make a list of the possible rational zeros, but the divisors of 1,000 are very extensive. I know that I'm a little bit limited on how big my dimensions can be, right? Because this was one of the dimensions, and it cannot be negative. So x can't be more than 15. The coefficient here being 1 tells me and combined with that, the idea that x has to be less than or equal to 15, because I can't have a negative dimension, tells me my possible rational zeros. Let's think about the divisors of 1,000 that are less than 15. It'd be 1, it'd be 2, it'd be 4, it'd be 5, it'd be 8, and 10, I think, would be it. So because of that, that's a little less bad. Remember, there's more, but none of those matter because of that condition, the requirement there. And remember, they'd all be over 1 because my coefficient here is 1. Okay, that helps a little bit. I'm also thinking, practically speaking, about this. None of the numbers can be negative because x can't be negative, right? So really I've narrowed it down to 1, 2, 4, 5, 8, and 10. A piece of luggage with dimension of 1 inch for its width or length or whatever doesn't make a whole lot of sense. I'm actually going to start with the bigger numbers here. So I'm going to start with 10 and see if that works. 1, negative 5, negative 150, and 1,000 are the coefficients there. Bring the 1 down, multiply, 1 times 10, add. Multiply, add. Multiply, I like it. I get 0 for my remainder. Check, that's what I'm looking for. That's good. That tells me that x equals 10 is a solution to the equation. It also tells me that I could rewrite this equation as 0 equals x minus 10 times x squared plus 5x minus 100. Which does not factor. There's no two numbers that multiply to give me negative 100 that add up to 5. I'm going to use quadratic formula on that last part. Remember, I'm looking for two solutions. This solution, actually, before I do that, to find another solution, it says find two possibilities. This one right here is going to give me the luggage can be 10 inches is the x. One of the other dimensions was the x plus 10, so that would be 20 inches. by the other dimension was 30 minus 2x. If you recall, you could flip back to that picture, but we had x, a height. I think we called this one 2, no, not 2x. X plus 10. I think the front one we called x plus 10. And this one we called x. And then the height here ended up being 30 minus 2x. And we did some work. If we plug 10 into that, we get 30 minus 20, or 10 inches. So that's one possibility, is that it's 10 inches by 20 inches by 10 inches. That does indeed meet the requirements that the sum of the three dimensions is 40 and the volume is 2,000 cubic inches. The other possibility is going to come from here. We're going to try to solve that with the quadratic formula. -5 plus or minus 5 squared minus 4 times 1 times -100 all over 2 times a is 1. -5 plus or minus, that's 25 plus 400, so 425 over 2. 425 is not a perfect square, so it doesn't simplify to a exact number or an integer there. So I'm going to approximate it. It says round to 1 decimal place. So square root of 425 is 20.6. So -5 plus or minus 20.6. I'm actually going to do a couple extra spaces and then round at the end just to make sure. I actually would probably put the whole thing in my calculator all at once instead of rounding at this intermediate step, but that's okay. The negative here, -5 minus 20.6155, doesn't make sense at all. That's going to give you a negative number. So I'm going to take that 20.6155. I'm actually just going to use the square root of 425, so I'm not rounding at all. The positive of that one. Subtract 5, hit equals, and then divide the whole thing by 2. Gives me, I don't want an equal sign, I want an approximation of 7.8 if we round to 1 decimal place. That tells us the other possibility is that it is 7.8 inches for my x by 10 more than that is 17.8. And then if I do 30 minus 2 times that, multiply it by 2, and then 30 minus that gives me 14.4 inches. I want to do a quick check to make sure that that meets my requirements. So I'm going to add up 7.8 plus 17.8 plus 14.4. I'm just throwing this in my calculator. And it gives me 40, exactly. That's good. I also am going to multiply them. 7.8 times 17.8 times 14.4 to make sure I do get 2,000, because that's what the volume I needed was. It's 1,999.296. That's rounding error. So good enough. These are our possibilities. We have 2 different possible suitcases that would meet this requirement. Okay, but notice we needed to be able to use this new technique on this cubic function that we don't know how to factor except with these new techniques. One last thing in this section I wanted to address. When we saw imaginary solutions up above here, we got 3 plus or minus I. That plus or minus came from the quadratic formula, right? That's where we got the I, is from that root in the quadratic formula. That is always going to happen. If a plus bi is a 0 of a polynomial, then a minus bi is also a 0. They have to come in pairs because of that plus minus in the quadratic formula. The same is true of irrational zeros. So the only difference between these two things is that the c would be a negative number in, oh, excuse me, would be -1, excuse me, in the answer above. So it's just a matter of whether or not you get a positive or a negative inside that root. So irrational roots also come in conjugate pairs. This question says find a 6th degree polynomial that has 3, -4, 2 plus I, and -√7 as zeros. 6th degree polynomial has to have 6 zeros. We have 4 given to us, but really we also know that 2 plus I is also a 0 because the conjugate pair of that complex or imaginary solution. Same thing with positive √7 is also a 0. That means my polynomial is going to be having a factor of x minus 3 from that. It's going to have a factor of x plus 4 from that. Now we're going to have x minus 2 minus I and x minus 2 plus I. I would not distribute that out. I'll show you why here in a second. The negatives here. We're also going to have x minus √7 and x plus √7. X minus √7 comes from this guy, x plus √7 comes from that guy. Remember, it's always x minus whatever the root is. We do not typically see polynomials this way. I am going to leave those in factored form, but these we don't typically see imaginary numbers in a polynomial, and even to have these roots here is a little unusual. So I'm going to distribute out these two and see what happens. X squared minus 2 plus ix comes from the outside, minus 2 minus ix comes from the inside, and then plus 2 minus I times 2 plus I. That is all inside that big parentheses from, let me do a different color here. Multiplying these gives what I just wrote here. Now let's do the blue. Go back to the blue. We'll distribute this out. X squared minus, oh wait, we'll do plus √7x minus √7x for the outside and the inside. Then when I multiply √7 times √7, I just get 7, and it's negative. So I have x minus 3 times x plus 4. I'm going to come back to that. Well, no, let's go ahead and clean it up. X squared. I think what has to happen here is we have to distribute this. So we get minus 2x minus ix minus 2x plus ix. And then here we have to multiply those. We get 4 plus 2i minus 2i, which is going to go away, and then minus I squared. Fortunately, this last one simplifies pretty nicely to x squared minus 7. We just have one more step here. I just really don't like having those i's in there, which is why I'm doing this. The minus ix plus ix goes away. 2i minus 2i goes away. Those are both 0 when you add them. One thing to remember is that I squared is equal to -1. So I have minus -1 right here. So I have x squared minus 4x plus 5. And then x squared minus 7. this would be a common way to see this polynomial function. That would be a 6th degree polynomial if I wrote it out, and it has all of those zeros. This also could have a number in front here, right? What's your favorite number? 16? This constant in front doesn't change that. That's it for polynomials. This is wrapping up our study of polynomials. We are going to see them again, just like I said with lines and parabolas. Those things are going to come back, but for now we're just studying these each type of function here individually, and then we'll have reference to them again later. We are going to rational functions after this.